So we are live, my friends. Yes. So today we are going to talk about optimizer, prompt optimizer in particular. And you can see here, this is a new app. I have invested quite a lot of time in this after I found that basically there was being done some research on this topic. And you can also basically just use Python to really use sophisticated programs that try and error through your prompt and iteratively improve it. Also with like statistics and evaluation in the end. But then I thought, yeah, so those tools, they are still more like research papers. And so I thought that it would be better to have something that everybody could use, that is super simple, zero friction, and that is still even more powerful than those papers that were published around 1 or 2 years ago. So AlphaFold was published roughly 1 or 2 years ago, and it made huge waves. So that's why I also described this a little bit on the PromptPotter website. So this is available to you. So for some free information. And yeah, you can really read a lot about Prompt Optimizer, and it's also still work in progress. So here is some section about prompt program evolution, which is like a larger class of prompt evolution and prompt optimizer. And here you can see that this prompt optimizer, they are nothing new. The only thing is now very special, and we can leverage AI as an orchestrator. Like most of the time, prompt optimizer are just a simple loop. So you generate some candidate, then you score them, then you evaluate it, and with this evaluation, then you feed it back into the generation node. And this was done. This has been done for years, just more rule based. So, but now we can basically leverage AIs to generate these new configurations. Previously, we had to generate these configurations differently, and we could not really rely on language and something slightly related to a world model. So they have a small world model, and they can kind of understand semantics, and yeah, they are kind of parrots on steroids. And now that these things, they're actually pretty smart. And the thing is, now we made this optimizer loop, which occurs everywhere basically. And with this loop, you can it's super powerful. If you have the right computation, then basically Google with AlphaEvolve was able to do a mathematical breakthrough. So this is the Strassen algorithm. It was discovered in 1969, and it was an algorithm that required 49 operations. And then Google used AlphaEvolve in 2025, and for the first time in half over a century, they improved this. So, and what they got out of it is huge. So they got a gain of zero point zero 0.07, no, zero point 0.7, wait, 0.7% compute recovered across Google data centers. So this is pretty significant and saved them a lot of money. And they used exactly the same AlphaEvolve to, yeah, as they said, this is program evolution to optimize many more processes in their company. And the problem now is with that is it's probably not very user friendly. For me, also until recently, it was actually not released nor not available for businesses. But now, 2026 January, they started releasing it, and now you actually everybody with a Google subscription can have it. However, what we are looking at now right now is like this PromptPotter. Today I made a new release with some other details coming up soon. And so let's look at this. Repositories. So the comparison AlphaEvolve and PromptPotter, they are very similar. The thing is, however, PromptPotter is 100% open source. So you can download it and use it on your own machine, and you don't have to trust me. You can look at the code, you can use your own API keys, and yeah, use the cheapest models that brings you the best results. So here, it's very simple, as I explained. It's just describe your task, drop a labeled data set so that we can measure whether it improves on the task, and then just start the loop. Okay, I hope you're still here, and I hope I have awakened your interest. And now, how can you use this? The easiest way is you go to the PromptPotter website and you just say, yeah, try it for free. And you can here log in with your Google account, and then basically you're in. And I give you some credits so you can work with it and test it out yourself. Then if we want to make a new chat, a new campaign, a new optimization, then we basically just click on the new campaign button, and we will get directed to this new campaign window. And here you can just drop your file. So in our case, we will use the PromptPotter, the Swiss invoices eval. So this is a task where you basically get a document, a text document, which is an invoice. And then the problem is that you have to find out to which category this invoice belongs. And this is a task where people in the offices, they cannot just do this right out of the stand. They still have to learn this and invest a little bit of time to know which class it is, because these classes are 4 integer classes, for example, 6400 or 8000 or 3001. And they are highly specific, and yeah, so they need to be learned. And the humans would probably take this multiple days or weeks. So with this, we can really just drop no description at all, and it can learn it from the bottom. And yeah, this is possible not with Claude Code. Actually, you can use a much cheaper model. Right now, I am orchestrating the optimization loop with DeepSeek version 4 Flash, but not the recent version, the one from April. And then I use this to optimize a model doing the task, which is the GPT 20 billion OSP model, which is super fast. And normally it takes it only 2 to 3 seconds to find out or to propose one of these numbers. Whether the number is correct or not, then is part of the evaluation. But once we have optimized the prompt for that, we can really run that process on this super cheap model. So we have dropped this evaluation set, and because we have dropped it before, we get a short message. So should we use the existing one? Let's just keep the old data as a version. Doesn't matter much. And then here we describe the task is to assign 4 integer codes to the invoices. the company receiving the invoices is using the most conventional Swiss small to medium sized businesses. And then we have like, this is also a language model, the check-in model, which basically turns and refactors all the things that we give, turns it into the right structure, and creates for us basically the origin to work with. And this will be our baseline. So sometimes this works, sometimes it doesn't. It should have already basically find out that the two columns are these two. So this is the expected account. This is the code that it needs to be found out. So this is really supervised training of large language model, basically, but without changing the weights. And so, yeah, so this is the labeled data. And this is the pipeline that we use. For us, we only use a language model, but I built this quite extensive. So it is possible with Prompt Optimizer, I mean with PromptPotter, to optimize not only LLMs, but also other things. So here to the overview, this is the loop, generate, score, critique. And the thing is, you can basically attach to this scoring everything that is in the internet. So normally it's not just a simple language model. Most of the time it's like a multi-step pipeline. For example, first you have a web search, and then the AI, and after that you have some case specific method to re-rank them with rules. And yeah, so our LLM, you can then, for this pipeline, you can then say, please optimize me the web search and the LLM. And then it will keep the ranking parameters, it will keep constant, and it will only try to optimize and find the best joint configuration of the other two nodes. Basically given the ranking configuration, which it is not allowed to touch. And so back to the web app, we haven't started. Where is it? Here we were. So here this is just a suggestion, and we just go with it. And then it will start. So this is still the check-in. We are now collecting the baseline, and you can see the results come in fast. In the background, this is running, and you can see they always take roughly quite a short time. Sometimes there are some hiccups, but yeah, they shouldn't be a problem in general. I also did a mistake. I actually sent this. I'm using the website now. So this is the website, and I just recognized this is the old version. This is still the old version, not the one from today, but it still works. Yeah. So if you like this, I'm going to talk more about this like every week, and I'm going to talk about different models, different data sets. I'm also going to talk about optimizing the optimizer itself. I'm already doing this, and I expect large gains from that. So you can see here, this is all optimizing the optimizer itself. And for example, here, this configuration will be used to evolve further. It's already better than what we are running on right now here. Okay, so what can we see here? The origin, the baseline was created, and when we click on here, yeah, that's fixed now. Okay, let's just keep this paused and look at one of my other runs. So let's go here, Swiss invoices eval 1. And basically what you can see is it can improve quite a bit. So at the beginning it wasn't able, and here it got every third almost right. And here I stopped it because it reached the budget. Although it says finished, actually it reached the budget. But the budget was really, really low. So this, for this improvement, we pay only like, where is it? Yeah, I think it's 3 cents total, 3 cents, something like this. And yeah, so let's see how our one's doing. Okay, it is now scoring the first candidate. And we can actually accelerate this by clicking this button. So in this case, it will always work on 2 sample points at the same time. Now it's roughly double the speed. So I think 2 of the most important features I still haven't introduced yet. So the first is that we're always sorting and testing on the hard samples. So this means if we have we have a sample which is always correctly solved, then we're not really gaining any information how good our prompt is if we test it on that. The same thing is true if we test it on a sample that is always false. Then we don't get any signal. All of the prompts, whether good or bad, they are not really in the region where we can use that sample to get signal. So for this, if we go to the chat, here is basically a hard sample leaderboard. And you can see it sorts them according to how much signal it gets out of that sample. So here it gets more signal, and here it gets less signal. And for those which are always correct, we don't have it here. Yeah, but this is super crucial. That way we can really get the best information as soon as possible. And the second thing is also that we have an early abort mechanism. And so as soon as it finds, actually we call this the probability of being best, POBB. And this means as soon as the probability of being best is not really, yeah, is very low, then we basically stop. And yeah, so that way we can save time and save money. Then here, where are we right now? We are at round 2. This one was scored. It's still running. So these are the hits and the misses. Okay, now it's here, which means this one is now inactivated again. This every round it stops. This is like a safeguard that we don't have runaway costs. But for this live stream, I accelerated again, and now for these 3 candidates should take roughly half a time. So this is the same data set. Um, yeah, but this is with the most recent code, so that there are not so many bugs for the display. Um, then how do we then, because of this hard sample, the pool on which we evaluate is always drifting. So how can we then find, if we evaluate each candidate on different samples, how can we then compare them? Because the samples are continuously getting harder. Um, so that is why we really have to, we cannot just, here you can see this is the accuracy, but we cannot just look at the accuracy. We also need to look at other factors. And so in this case, this is the theta. And if it's positive, it it made a better prompt basically, and if it's negative, then yeah, it didn't make a better prompt. And then you can also maybe customize your fitness scoring function. You say, okay, for me speed is more important, or for me cost is more important. Then you can basically generate your own scoring function. So you can then also look at what if, like, if I would have changed my scoring function, how much of the tree that we built would still be valid. So this is a bit complicated, so I will not go further into this. I will just hide it again. We can also hide this. This is just the same tree like this. And but what we want to see is basically this one here. This has a little bit of bug. Okay, let's not show it. Yeah. So you can see you can do a lot with it, with this optimizer, which you cannot do with all the other programs, particularly DSPy, which is like one of the most frequent used setup with I think it's Capo. Yeah, that one that one is the most one used, but clearly these are Chipa is the most used. And I would say this new program is in all matters it is superior, clearly, because it is basically competing with Alpha Evolve, just on different axes. So Alpha Evolve also has statistical pruning, but already this GEPA doesn't have that. And I mean, without statistics, how can you guarantee that you're being efficient? And yeah, so only with statistics you can really get down to efficiency where you have hard numbers and you're not just guessing. And yeah, so uh, I don't know how good GEPA is, but this will be another video. We're going to benchmark them and see how this works. Then carries knowledge forward. So when we do a campaign, we store all the information, and if a new campaign uses the same configuration, proposes the same candidate, then it doesn't recalculate it, but simply takes it from the stored data points. And I mean, this one is a big one. GEPA actually can do it, but Alpha Evolve is really for code. Like Alpha Evolve optimizes math problems and code. And of course, I think it likely can also do prompts if you configure it. There should be no reason why this couldn't work. But yeah, for us, it's just much more convenient, and you can just hook it up to any kind of connector through a REST API, various things possible. And yeah, this is a little bit a repetition, similar we just said. And yeah, so guards against self-validation. As yeah, this there is this statistics in there, and it at the moment it doesn't change the evaluation, so it doesn't have any influence on the evaluation, so it cannot really hack the reward system. And this is also an interesting feature, the self-healing. So whenever prompts are large language models are really hard. Sometimes they just meet some anomaly, and if that happens, then you don't want to say explicitly, "Hey, never do this anomaly again," because then you have like a sentence which is very specific, and for every anomaly, you get a new sentence. And this kind of issues is better solved with I call this self-healing. Like instead of placing such a sentence there, the 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 drift will still be recognized and recorded and even scored, but we don't put like specific things there, but instead we just bring the whole LLM in a little bit away from that particular anomaly manifold. Like go out of that valley, go beyond a few hills, and then that anomaly can never happen again. And yeah, so neither GEPA nor AlphaEvolve has a very good user interface. And yeah, this is just so important. The zero friction is really important. And for you, if you want to try this, I would recommend you first, the easiest thing, just zero setup, log in, and you can use it. Then if you like to use it and test it more, then you can basically, what I would do is I would just download VS Code, use this, open Claude, and then just tell it like, please clone the PromptPotter repository from GitHub. Then it will basically go to the release page or read, and it will get you the pip command. It will download you all the stuff, and after that, when you have everything on your machine, you can just do the Potter run, and when you do this, it will know exactly what to do, and it will set up all the stuff for you. This is just a different entry point than using the chat interface. So basically, the Cloud Code then basically has direct access to this tool, and it can solve every small problem. So most of the time, I am not doing manual front end operations, but just talk with Claude, and he's basically operating the whole PromptPotter tool. Yeah. So this is the real overview, and you can see if we now look at the performance of the other one. Where is it? Here apparently it found a very good candidate, and after that it didn't progress. And all of this cost us 2 cents. So from point 0.05 performance to 0.45. And yeah, so this is still work in progress. You can see it works kinda, and it's only going to work better. So if you like this, please tell it to your friends. And if you know any alternative, yeah, maybe I'd love to look at the competitors. Maybe I can adopt some of their little hacks and improve this tool. But so far, this works really nice. And yeah, the UI is still a big mess, but all the mechanisms behind are ready for you to use. And yeah, since there are no questions in the chat, I will call this a day, and we see us in a week. Bye.